So our goal today is to be able to read and write numbers in scientific notation. Tomorrow we will work on multiplying and dividing numbers in scientific notation. So remember the Tower of Hanoi that you just did on Desmos? Every time you added a disk, the minimum number of moves got much bigger. This is an example of an exponential function, and it can be modeled by the equation y equals 2 to the x power minus 1. So let's use Desmos to see how many moves it would take for 8 disks, 20 disks, and 64 disks. So you're going to go to Desmos and evaluate the following. So in row 1, type in what you see here. Y equals 2 to the 8th minus 1. You'll need to use the A to the B button, and then you'll also need to use the arrow to make sure you get out of the exponent. Then you're going to evaluate y equals 2 to the 20th minus 1, and y equals 2 to the 64th minus 1. Head over to the Desmos app to do that, and then write your answers here when you're ready. Pause the video, press play when you're ready to write your answers down. So on Desmos, when I entered these exponents to evaluate, 2 to the 8th minus 1, I got an answer of 255. That means it would take a minimum of 255 moves to complete the Tower of Hanoi with 8 disks. For 20 disks, it would take a minimum of 1,048,575 moves. And with 64 disks, it would take this many moves. So which of these three would actually be the largest answer? Well, clearly it would be the one with 64 disks. But if I look at that, this starts with the 1.8, which is actually the smallest number of all. So the reason that's the case is because it has this exponent of times 10 to the 19th. And so this is an example of scientific notation, how we're going to learn to read and write numbers today. So standard notation is a way of writing numbers using traditional place value. So for example, to write 3,527, it would be 3,527. Scientific notation is a way of expressing a number as a power of 10. So the format is C times 10 to the n. I like to think of C as like my stem number. It's always going to have a power of 10, and then n is going to be my exponent. And this x right here is going to mean times. It's not a variable. So some of my requirements are going to be that this C number has to be between 1 and 10, but according to this inequality, it can equal 1, but it cannot equal 10. And that n, which is my power of 10, must be an integer. So this means it can be positive and negative, but it can't be a fraction or a decimal. If the power of 10 is positive, so that number right here, n, that's going to mean to move my decimal n places. So let's say it was 5. I would move 5 places to the right if it's positive. So move 5 n places, whatever that number is, to the right. So if it's positive, I'm going to go to the right. If it's negative, I'm going to move the decimal n places to the left. So a negative is going to mean to go to the left. So this number right here, this n, it can be positive, it can be negative, but it can't be a fraction or a decimal. It has to be an integer. Positive would mean to move whatever this number is to the right, and negative would mean to move whatever this number is to the left. We're going to move the decimal. So first, let's practice converting numbers from scientific notation into standard notation. So first, I notice that I have my C number here, which is 2 point something. So 2 point something is between, remember that restriction was that C had to be between 1 and 10, and that it could equal 1 but not 10. So 2 is certainly in between 1 and 10. I know there's extra decimals here, but 2 lives somewhere in this space. And my power of 10 is a positive 6. So because it's positive, that means I'm going to take my decimal and I'm going to move it 6 spaces to the right. So I'm going to go 1, 2, 3, 4, 5, 6. Now I have these 2 little extra spaces here, and so to fill those extra spaces, what I'm going to do is I'm going to use zeros. So I have 2, 0, 0, 7, 5, 0, 0, and then I'll work backwards, and I'll fill in my commas. And so 2.0075 times 10 to the 6th is the equivalent of 2,007,500. On example 2, here's my decimal point, and my exponent is negative, so that means that I'm going to move it to the left, and I'm going to do it 4 spaces. So I'm going to take that decimal, and I'm going to go 1, 2, 3, 4. And every time that I had an empty swoop, I'm going to put in some zeros. So here I've got 3 zeros and then 1, 6, 8, 5. So what I've just done is I've taken these two examples in scientific notation expressed as powers of 10, and I've put them in standard notation with normal place value. So what you're going to do right now is you're going to pause the video and you're going to try examples 3, 4, 5, and 6. Look at the power of 10. If it's positive, move it right. If it's negative, move the decimal left. However many spaces this power tells you to go. And write your number in standard notation. Pause the video, press play when you're ready to check your answers. So on example 3, my power of 10 was positive 5, so that meant to go 5 spaces to the right. That ended up with 702,350. On example 4, my power of 10 was negative, so it meant I was going to go negative or 7 spaces to the left, which means I was going to have 6 spaces to fill with zeros, and then my 3096. Example 5, I was going to go 4 spaces to the left, so 0.00045. And then on example 6, I was going 5 spaces to the right, and this came out to 362,000. So now we're going to put numbers from standard notation into scientific notation. So the first thing I have to do is remember that that starting number, or that like stem, that C, has to be between 1 and 10. It can equal 1, but it can't equal 10. What that's going to mean is that you're going to take the decimal and put it so that way there's one digit before it. And that digit either needs to be a 1 through a 9. So 1 point something, 2 point something, 3 point something, up to 9 point something. If it was 0 point something, it wouldn't be at least 1. And if it was 10 point something, it would be too high. So you want one digit here that's between a 1 and a 9. So right now I can see that the decimal lives at the very end of my 42,590,000. So I want to start with it between the 4 and the 2. So if I do that, it's going to be 4.259. The idea of scientific notation is it's allowing you to write numbers without all these extra zeros. So now what I want to do is I want to imagine that my decimal is here between the 4 and the 2. And I want my exponent to tell the reader where they should go with this decimal. So the first thing I notice is that to make this back into 42 million, I want them to go to the right. So I want this exponent to be positive. And then I would just count. 1, 2, 3, 4, 5, 6, 7. So if your reader took this as a roadmap and started with 4.259 with the decimal here between the 4 and the 2, and they looked at this exponent, it would tell them to go 7 spaces to the right, and when they were done, they'd get back with the number 42,590,000. You want to make sure this number tells them which direction they should go, not which direction you went. So as the reader, you want to tell them that they want to go to the right. Let's look at the next one. So my decimal is clearly here. The previous one was invisible. Here it is, and I want to start by putting it between the 5 and the 7. So I'm going to start with 5.74. And the reason for that is because now my C is between 1 and 10. It's 5 something, which is between 1 and 10. Now you want to tell your reader that they want to go to the left because they want to make this into a smaller number, and you want to count out the number of spaces. So I'm going to start between the 5 and the 7 because that's where it is here. And I'm going to count back until I hit the decimal. 1, 2, 3, 4, 5. Now the fact that I'm going to the left means it's going to be negative, and I wanted the reader to go 5 spaces to the left. So if I gave this problem to you and asked you to do it, you would look at this and say, hey, let me move the decimal 5 spaces to the left. And when you did it, you would end up with this original number here. So what you're going to do in examples 9, 10, 11, and 12 is you're going to put this in scientific notation. So they all should look like this when you're done. They should be a C times 10 to the something. Make sure that that exponent tells your reader which way they should go and how many spaces, and that your decimal only has one digit to its left, so that way the number is between 1 and 10. Pause the video, press play when you're ready to check your answers. So on example 9, I started with the decimal between the 5 and the 3 because that would put the C value between 1 and 10. And then my exponent should be positive since I'm going to want my reader to go to the right and 1, 2, 3, 4, 5 spaces. So my final answer is 5.39 times 10 to the 5th. On the next one, my decimal is going to start between the 2 and the 6. And then I need my reader to go to the right, so that means my power of 10 is going to be positive, and then I just counted it out until I got to the end. 1, 2, 3, 4, 5, 6, 7, 8. So 2.675 times 10 to the 8th. On the next one, I started with the decimal between the 4 and the 8, and I was counting back to the left. So that meant my exponent was going to be negative, and I went 4 spaces. So 4.86 times 10 to the negative 4. So on the next one, you might be thinking, well, wait a minute, this is already in scientific notation. The problem is if I look to the left of my decimal, this is 37.2, and my C number, again, is supposed to be between 1 and 10. So 37 is far above 10. So this decimal is starting in the wrong space. But let's pretend for a second that this was in scientific notation and that it was okay. Well, my exponent would tell me to move this decimal 3 spaces to the right. So the decimal in standard notation is 3 spaces away from its ending place, or its house. But it's almost like he's trying to get a head start in the race, and he's really supposed to be starting here. So when I take that decimal and I pull it back 1 space, it's getting 1 space farther away from its house. So here, the decimal was 3 spaces away from its house, and by pulling it back 1 space, all of a sudden the decimal is 4 spaces away. So now by doing 3.72, that's fine because it's between 1 and 10, but now the decimal has 4 steps to go and not 3. So 3.72 times 10 to the 4th.